Welcome back. In this video, we are going to look into the following topics. The focus of this video is going to be on data modeling. And we are going to do a basic brush up of the concepts of data modeling. We will then head over to Power BI and we'll see how to implement a successful and robust data model in Power BI and what is the impact of data modeling on visuals in Power BI. So let's get started. So let's look at this situation. We have employee demographics information, employee name, age, gender, employment type, city, state, salary, scores, lat long, etc. We have employees education information for a given employee, 10th score, 12th score, the type of college this employee passed out of, the kind of college, whether it is private or government funded. We also have information about sign-in and sign-outs at office locations by employees. So what was this time of sign-in, sign-out, which city the sign-in, sign-out happened, and what is the state. And we also have information about employee skills. So a given employee, what is the category, what is the skill in which the employee is rated, what are the points, how many problems attempted by the employee in that skill category. So looking at all this information, we have 4 different tables, and this is where the data model starts. If the information is coming in this way, how do we model the data so that data can be fetched from any table, data can be merged, aggregated and used for different use cases. So to do that, we bring in the different entities together. So for example, we have the employee demographics table. So what we do is we create a new sheet here and we just do a transpose. So this we have done this before. So this is my employee demographics, and then let's pick up the next one, which is employee education. So let's bring it here, employee education. We will give the name like this. So this becomes my table name. Then we have the table structure, which we can show like this. We can show the table structure also here. So we've got 2 tables ready, employee demographics, employee education. Or how about employee scans? Let's take this, go here, let's do a transpose, and I can apply the same format to all of them, and I go here, pick up the name, paste here, and this becomes my 3rd table. And similarly, let's bring in my 4th table, which has all this information. Let's bring it here like this one. Again, this will become the header, which is coming in from here. We put it here, and we use this one and format this. So you have got 4 tables created like this, and the principles of data model say that every table should have a column which should be able to identify each record uniquely, which we have employee. We have the employee code in this table, which is uniquely identified because it is for each employee. Here also it is employee code, because it is identifying the education qualification of each employee uniquely. Here it is not just employee code, because an employee can sign in and sign out multiple times. So we have scan ID. Here we have the skill item ID, because employee code is again not unique here, because an employee can have multiple skills. So this also helps to understand what will be the relationship between different tables. And when we are talking about relationship, we are talking about logical relationship. So we understand that we know that an employee can have can have a single record of education. So this one and this one, they have a 1:1 relationship. An employee can scan multiple times. So this one and this one, this is going to have 1-to-multiple or 1-to-many relationship. Similarly, from employee code to employee skills, one employee can have more than one skills. Again, this is 1:many relationship. And this is what is data model all about, that you bring the different tables together and you identify the relationship between them. You decide what is the cardinality of the relationship, and your data model is ready. So with the basic understanding of data model ready, let's go back to Power BI and see this in action. Now I am in Power BI, and where do we go for data modeling in Power BI? The model section. When we come to the model section, I can see there are these 4 tables: employee details, employee skills, employee education, and employee scans. They are available. And we see there are these lines going from table to table. There is one written here, there is star here, there is this arrow, there is a single arrow, there's a double arrow, there's double arrow. What is happening here? So we are going to spend some time in implementing the data model in Power BI. So to start with, let's start fresh, where suppose we do not have any relationship. So we are going to build the relationships from scratch. So for that, let's go to manage relationships. There are some relationships already existing. I select them and delete them one by one. Alright, so all these different tables are now independent. So let's go to our data report section and let's try to build a visual. So I want to create a simple visual. Where I want to show by employee type the total number of points collected in assessments or in hackathon, overall in the LMS. And we have the points collected in the employee skills table, which is this one. So I bring in to y-axis, and what it is showing is there is a blank section, there is contractual, and there's permanent. We know that employee type, we have permanent, contractual, and there's one employee for which the employee type is not known, this one, right? So but what we see is all of them is showing 525 points. What is 525 points? If I go to employee skills and I select this one, it is showing that for whichever the category you are choosing, so if you are choosing contractual, total points is showing as 525, permanent it is showing as 525, blank it is showing as 525. So there is something wrong here. Ideally, how much it should be? So if I want to go by employee demographics, which are the permanent employees? Let's see that. Let's add a filter here. Let's sort this. So we have these 4 are the contractual employees, and for these employees I would like to understand the total points. So which is CA1001. So this is the first one. Then NY1003, do we have? No. TX1004, yes, TX1004, and MS1001, not there. So what is my total points? My total points, if I look at, is 525 here. That's the same value which it is showing. But is it that for both permanent and contractual it's the same? No. So if we look at it, if we go back, CA1002 is contractual, and TX1004 is also contractual, which means for permanent it should be 0, correct? So if I go here for permanent category, it should be 0 because both CA1001 and TX1004, they belong to contractual employee. So here it is showing wrong information. What is happening? What's happening is that you are involving two tables for this aggregation. You are having employee type coming in from employee demographics table, and you have the points which is coming from the employee skills table. So when you're using these two fields, these two tables, they don't know how they are related. So which means that for every employee type, it's going to aggregate the entire table. So because there is no relationship existing between them. So it's important that we establish the relationship. And we know that one employee can have multiple skills. So the relationship between this table, demographics, and the skills table should be 1 to many. So let's go ahead and create that relationship. Click on new. Left table will be demographics, right table will be skills. So, and see, employee code is automatically selected. It is saying 1 to many, which is correct. And then we have this cross filter direction, which is showing as single or both. We will talk about it later. And also it is saying that make this relationship active. We will talk about this also little later. But let's assume that with this, our relationship gets established, and I can say, okay, I have got this new relationship created here. I can say close, and that relationship gets reflected here, and it is depicting the same behavior 1 to many as we had created in our Excel based data model, 1 to many. Same thing between employee demographics and employee scans. One employee can have multiple scans, so you can go to manage relationship again, establish a new relationship again between employee demographics and employee scans. It is again 1 to many, single cross filter direction. Let's say okay, another relationship got created. Close and let's see. Yes, 1 to many. And for every employee there is a single record of employee education, so this should be 1 to 1. Let's see if it is able to do that or not. So between employee demographics and employee education, there is a 1 to 1 relationship, and cross filter direction is showing as both. We will talk about it. We'll say okay. So third relationship is also established, and you can say close. And what do you see here? The noticeable difference is that it is showing as arrows in both left and right direction. It is showing arrow in one direction. So basically this one and this one is having a single direction. It's not on both. But this one, it is in both direction, left or right. What does that mean? We're going to talk about it. So after establishing this relationship, if I go back, what do I see is the problem got corrected. Contractual employees have 415 points and permanent employees have 110 points now. So this looks realistic, that yes, there would be a difference in points collected. All right. Now let's understand what is the difference between the single direction versus both direction, which is mentioned when we go to manage relationship. In this one, if I do edit, we see it is showing as single, and this one, if I do edit, it is showing as single. This one, if I do edit, it is showing as both. What is this and what is this? Let's talk about this filtered direction. So if I create this visual where I want to show the total points collected, total points collected by employee type. So my dimension is in my left table. The slicer is on my left table, or the filter is on my left table. So employee type is the column or the attribute which is used to group the points. So, and we have two tables involved. So this direction is this direction means that when you are creating your visual, employee type is coming from left table, and it is impacting this is impacting the points column in the right table. In this one, in employee demographics and employee education, you see it is both. So which means I can in this case I can create things like employee type wise. I can find out the average 10th score, right? Or we can say college type wise average age, which means I am going the dimension not only from left to right in this case, but also from right to left. Let me show that with an example. So this is impacted because now the left table and the right table have a relationship. If the relationship was not there, it was aggregating to the to everything, which was wrong. If we look into this one between demographics and education, let's create a scenario where I would like to know employee type wise average 10th score. So I can go here and this will remain as employee type, and we bring in 10th score from here and we make it as average. So what we are seeing here is that this one is coming slightly different. Okay. Instead of that, if I go and create, if I go here and if I create, say, this one, college type wise or funded by wise, I would like to know average age. So I can go and instead of employee type selecting from here, and I'll be selecting say college funded by from here, and here I'm going to use average age. See, both of them are showing different values. So the filter action is affecting both sides, from employee demographic to employee education, from employee education to employee demographics. That's why it is bi-directional or both direction. But since the relationship between employee demographics and employee education is 1:1, bi-directional still makes sense, because in the end both are kind of single table. But what if I talk about employee demographics and employee skills table? If I want to talk about the relationship between the two, I am saying that the relationship is one-to-many. So I can start with a dimension in this table and analyze any fact in this table. So if I can go back, and we had already seen that, which was employee type wise. Let's bring in employee type, and wanted to bring in the total points, which is here. So we already saw this to be working. But what if I want to have the reverse? I want to have a skill category wise. I would like to know that by skill category, what is the average salary. So basically I want to show that whether hot skills like Python or Spark, they are the employees who are hired for these skills, are these employees have higher salaries too. So let's try that out. So in that case, my x-axis is going to come from employee skills table, which is skill category, and my y-axis, which is average salary, is going to come from the left table, which is employee demographics. So I'll drag and drop this here, and I'll make this as average. Yeah, so instead, sorry, not skill category, I'll try to make this as a skill item. And what we are seeing in this case is that by skill item, all the columns are showing the same, which means that the filter action is not working. And why it's not working? Because there is a filter action from left table, that is demographics to skills, but there's no filter action from employee skills, which is right table to the left table. This is a single direction filter. So I click on this relationship, I click on this relationship, and I can go ahead and make this both, and I can say okay. So it becomes a bidirectional relationship. So the filter action will flow from left to right as well as from right to left, which means if I go to the visual, now it gets corrected. So the idea is that the direction of filter decides whether the one table dimension is going to impact the fact. Basically, a slicer in a given table, will it going to slice the data in the fact given in another table. And if this is a single direction, the slicing will happen in only one way. But if it is both direction, slicing can happen both ways. That's the idea between single direction versus multiple direction. Next, let's also understand the idea of making a relationship active or not. We had seen that if you pick up any relationship and if you edit that, we have this option of make this relationship active. What does that mean? Let's look at the situation where we have the calendar table also as part of our model. And here in this case, if you see, we have the calendar table with the date columns, and in employee demographics we have joining date as well as leaving date. Let's look into our example here. So we have employee demographics, we have joining date like joining on 1st of April 2019 and leaving on 10th of June 2019. This employee joined on 1st of May 2019, has not left yet. This employee joined on 10th of June 2020 and has left on 10th of January 2022. So if I want to do analysis of employees or HR analytics based on joining date, we will get different trends compared to if we do the analysis based on leaving dates, right? So the relationship, if I want to perform this analysis between the calendar table, which is this one, calendar table which is having all the dates. If I establish a relationship between calendar table and employee demographics table, I can either do it on joining date or on leaving date, not on both at a single time. So at one time the relationship between calendar date and joining date, second time the relationship could be between calendar date and leaving date. So in other words, what we can say is at a time only one relationship can be active. Let's look at this in Power BI. If I go and say manage relationship and we create a new relationship, start from calendar and end at employee demographics, start from date, and if we say by joining date, so there is a relationship established and it is saying 1:1 direction both, that's okay. The important thing is that there is an active relationship established between calendar and the joining date. Now again, I want to establish a relationship between calendar and leaving date. So if I go to manage relationships and create a new relationship from calendar to employee demographics table, start with the date here, and we go to employee demographics, click on leaving date, and I say okay. If you see here, from calendar table to the employee demographics table joining date, it is showing as active and this is not active. If I try to click on this, it says relationship activation. You can't create a direct active relationship between employee demographics and calendar because an active set of indirect relationship already exists. So to make this relationship active, set the cross filter direction to single, delete or deactivate any of the other indirect relationships, right? So which means that if I say close, what do we see? We see between these two tables there are two relationships established, but the one with the solid line is the active relationship, the one with the dotted line is the indirect or inactive relationship. So if I want to make this active, I will go to manage relationship. First I need to make one of them as inactive. So with joining date it was inactive, I'll make it inactive, and with leaving date I will make it active. And when I close this, what happens? This becomes solid line, this becomes dotted line. So the point is, at a time between two tables only one relationship will be active, one will be inactive. So that completes the video on data modeling, how to implement them in Power BI. What does it mean by filter direction, filter action, and what does it mean by keeping a relationship active or inactive in Power BI. So hope the video was helpful. Thank you.